Okay, this video contains the solutions for 7172 multiple choice practice problems. First problem is asking to find a value k such that the area under the cosine curve from negative pi over 2 to pi over 2, some value k, that divides it into an area here that's 3 times as big as this area. So the first thing we need to do is figure out what that whole area is. And I'll leave that for you to figure out. The whole area would just be the integral from negative pi over 2 pi over 2 under the cosine curve. And that turns out to be 2. It's maybe worth knowing, we've seen that a few times, that the area under one bump of the sine or cosine curve is 2. So if we're going to divide it into two areas, one is 3 times as big as the other, that means this part will have an area of 3/2 and this will have an area of 1/2. So there's two ways to set up this problem. You can either set it up like, well, that means the area from k to pi over 2 under the cosine curve would have to be 1/2. Or you could also set up from negative pi over 2 to k, it has to be 3/2. Either way, I'm going to use this setup here. Okay, so the antiderivative of cosine is sine from k to pi over 2. It's got to be equal to 1/2. So that means the sine of pi over 2 minus the sine of k must be equal to 1/2. The sine of pi over 2 is 1. So that gives me sine of k is equal to 1/2. So k is equal to the sine inverse of 1/2. And that's pi over 6. Which is C. The second one, number 2, is the area of the region bound by the curve y equals 2 to the x-axis, the y-axis, and the line x equals 2. The e to the x function is one that you should be familiar with. Looks something like this. E to the 2x looks similar to that. It gets a little steeper, a little faster. And we want the area bound by that curve, the x-axis, the y-axis, and the line x equals 2. So we're talking about this area. And that we represent as the area from 0 to 2 under e to the 2x dx. The antiderivative of e to the 2x is 1/2 e to the 2x. You get that by doing a little u substitution with the 2x, or just knowing that if it's just a linear multiple, we just end up dividing by that. I've seen that enough times too. And that would be e to the 2 is 2 minus e to the 2 times 0. That's 1/2 times e to the 4th minus e to the 1, or e to the 0, sorry, which is 1. And that matches up to answer choice C. Number 3, region in the plane bound by the graph of y equals 1 over x and x equals m and x equals, sorry, a little too far, what, 2m? They're asking us a question about that area. So let's go ahead and find that. That would be the area from m to 2m under 1 over x. That's natural log of x from m to 2m. And they said m is a positive number, so I don't have to put absolute value signs here. That's natural log 2m minus natural log m. But by the rules of manipulating logarithms, that's natural log of 2m over m, which is just the natural log of 2. So regardless of what m and 2m are, that area always comes out to be natural log of 2. So the correct answer is A. It doesn't matter what m is. Number 4, we want, this is pretty similar to number 2. The area of the region bounded by the lines x equals 0, x equals 2, and y equals 0 in the curve. This time it's e to the x over 2. So I'll do this one quickly. It's very similar to number 2. It's this area. So going from 0 to 2 again, under e to the x over 2. X over 2 is the same as 1/2 x. So the antiderivative of that is 2e to the x over 2. You can do a u substitution there if you need to see why the 2 comes out. That's 2 times e to the 2 over 2 is 1 minus e to the 0 is just 1. So 2e minus 2, which matches up to answer choice C. Number 4. Oh, that was number 4. Just kidding. Number 5. What's the area of the region completely bounded by the curve y equals negative x squared plus x plus 6 and the line at y equals 4? Let's make a quick sketch here. So the line y equals 4 looks like that. And minus x squared plus x plus 6, that'd be an upside down parabola. So let's find out where they intersect. If I set them equal to each other, and 4 is equal to minus x squared plus x plus 6, and getting everything on one side and factoring that, it looks like they intersect at negative 1 and 2. So it's some region like this. I know the parabola is on top because it's a downward opening parabola. So that means we're talking about the area from negative 1 to 2 under parabolas on top, minus x squared plus 6 plus x plus 6 minus 4 is on the bottom, dx. I'm going to go ahead and simplify that first before I take the antiderivative. That's minus x squared plus x, 6 minus 4 is 2. You don't have to do that, but it makes it a little bit easier, I think. The antiderivative of that is minus x cubed over 3 plus x squared over 2 plus 2x from negative 1 to 2. I'm plugging 2 in there. It gives me minus 8/3 plus 2 plus 4 minus, plugging negative 1 in here, I get minus 1 minus 1 plus 2 and, oops, sorry, minus 2, isn't it? Let's just check that real quick, make sure I didn't make a sign mistake. Plugging negative 1 in here gives us minus 2. So that's all negative 4, so I've got a plus 4 from that. And then this is doing this, wait a second, hold on, let me just check this here. That's right, but plugging negative 1 in here, negative 1 cubed is negative 1, the negative sign, I don't know where I got that 1 from, that should be plus 1/3. So scratch that. Alright, so here, let's try this again. We have making all of these thirds, that would be 6/3 and 4 is 12/3. So I've got 18/3 minus 8/3 is 10/3. And then here I've got, that's minus 3, that'd be minus 9/3, so that'd be minus 8/3 plus 8/3. And that is not going to give me the right answer, is it? No, it's because I made another mistake here. Plugging the 1 in here, that gives me minus 1/2, not minus 1. So let's fix that again. So let's see, common denominator between 3 and 2 here. That'd be plus 2/6 minus 3/6 minus 12/6. So that's, let's see, 2 minus 3 is negative 1, so it's minus 13/6. I think we're on the right track now. And so changing this, that's 20/6 minus 13/6, which is 7/6, which is still not the right answer. Alright, let's go back and check this again. So plugging 2 in here, we've got 8/3 plus 4/2 plus 4. Okay, so this is right. And then plugging negative 1 in here, I get negative 1 cubed is negative 1, and then negative sign makes positive. Negative 1 squared is positive 1, so that, oh, geez. So that's going to be plus, so that's 5 minus 12 is negative 7/6, right? And that gives me, and then there was a minus sign in front of all that, so makes that plus 27/6, and reducing that by 3 gives us 9/2, which is the correct answer. So obviously, you've got to be careful with signs there. Easy to make a mistake, but that's the correct answer. Number 6, region of the first quadrant bounded by the graph of y equals secant x, x equals pi over 4, and the axis is rotated around the x-axis. Well, the cosine graph looks like this, right? So the secant graph is that turned upside down, and all the places where the cosine graph was equal to 0 turn into vertical asymptotes. That happens when you try to divide by 0. So we're talking about this area right here under the secant graph. So that's from 0 to pi over 4 under the secant graph, but we're rotating this around the x-axis like this, so you get sort of a lampshade type thing, and so it's pi times this squared dx. The antiderivative of secant squared is tangent, so that's pi times tangent x from 0 to pi over 4, which is pi times tangent of pi over 4 minus the tangent of 0. And tangent of 0 is 0, so that's pi times tangent of pi over 4 is 1. So the answer is pi, which is C. Number 7. The area of the region of the first quadrant that's enclosed by the graphs of y equals x cubed plus 8 and y equals x plus 8. Well, you know what the x cubed function looks like, so x cubed plus 8 would just be that graph shifted up 8 units, and then y equals x plus 8 looks like that. And the way my sketch looks, it looks like those areas aren't the same, but by the symmetry of those graphs, these are two equal regions. Notice that they trade which function is on top here, but I'm just going to say that these two are equal. So I'm going to say my area is 2 times the area from 0 to 1 and from 0 to 1 the x plus 8 is on top minus x cubed plus 8 and excuse me, the 8's cancel out. Taking the antiderivative, The 0 is going to give us a 0 there. And it's 1/2 minus 1/4, which is 1/4 times 2 is 1/2, which is B. See if we can squeeze in number 8 at the bottom of the page here. Region enclosed by the graph of y equals x squared, the line x equals 2, and the x-axis. Y equals x squared, the line x equals 2, and the x-axis is revolved around the y-axis. That means this is going to be a dy problem. So we get that. Now, let's see, that's x equals 2. And this would be the point 2, 4 on that function, right? So we're going to slice across this way. And y equals x squared, when we solve it for x is equal to the square root of y. So, let's see, if pi times the integral of the outside radius of this thing as we slice across this way is 2 squared minus the inside radius is the square root of y squared dy from 0 to, you got to be careful here, we're going to go 0 to 4, right? This is a dy problem, so these need to be y values. That gives me pi times the antiderivative of 4 is 4y. Square root of y squared is just y, so that antiderivative of that is y squared over 2 from 0 to 4. And that gives me, the 0 is just going to give me zeros in there. 4 times 4 is 16, minus 4 squared is 16 over 2, minus 8, which is 8 pi. And I feel like that we did an example just like that in your notes. So if that one seems kind of familiar, I think it comes straight out of your notes. Number 9. We just have a region here. I'm going to bring up here's the picture. And they want to know what's the area of the shaded region. Well, we just have like this curve on top and this one on the bottom. So that would just be the area from -1 to a of, and then the f of x curve is on the top. The g of x curve is on the bottom. That's all. Nothing more to that problem than just knowing how to set that up. And that's answer choice D. Number 10. Base of a solid is the region enclosed by the graph of y equals e to the negative x. Putting the negative there just flips the e to the x function like that, right? The coordinate axes in the line x equals 3. So we're talking about this region here. That's x equals 3 right there. If all plane cross-sections perpendicular to the x-axis are squares, so each one of these little cross-sections here is a square, and the side of the square would be the function, which is e to the negative x. So we want to take the integral from 0 to 3 of the area of each one of these. And the area of a square is the side squared. So 0 to 3, the area is e to the negative 2x. The antiderivative of e to the negative 2x is e to the negative 2x divided by negative 2 from 0 to 3. Gives us negative 1/2 is e to the negative 6 minus e to the 0, which is negative 1/2 times e to the negative 6 minus 1, and that's equivalent to answer choice A, because if you distribute the minus sign, it's going to flip the signs of those. Number 11. Number 11, let's leave that one for last. Number 12. The area of the region enclosed by the graphs of y equals x and y equals x squared minus 3x plus 3. That's an upward opening parabola. And y equals x, so the line will be on top. Now let's find where they intersect. Set them equal to each other. See if I can do this one without making a sign mistake. So factoring that, we find that they intersect at 1 and 3. So we want the integral from 1 to 3. The y equals x is on top, minus x squared minus 3x plus 3 is on the bottom. Now that's minus x squared plus 3x, plus 4x, because of that x there, plus 3x minus 3. Antiderivative of that is minus x cubed over 3 plus x squared, 2x squared minus 3x from 1 to 3. Plugging the 3 in, 3 cubed is 27 divided by 3 is 9. 3 squared is 9 times 2 is 18 minus 9. Well, that's nice. That all just comes out to be 0, right? And then plugging the 1 in here, I get minus 1/3 plus 2 minus 3. So putting all these in thirds, 2 is 6/3, 3 is 9/3. So I have negative 1/3 plus 6/3 is 5/3, minus 9/3 would be negative 4/3. 2 minus signs cancel out, and we get 4/3, which is C. Number 13, the volume of the solid obtained by revolving the region enclosed by the ellipse around the x-axis. All right, I guess we could talk just for a second if you want a visual here. What does this ellipse look like? To get this into standard form, it would be x squared over 9 plus y squared equals 1, right? Dividing everything through by 9. That means this ellipse has, in the x direction, it's stretched by 3. And in the y direction, it's stretched by 1. So it's this ellipse, right, centered at the origin. And we're going to revolve the whole thing around the x-axis. So it's going to spin into like a football sort of shape. So just taking the top half of that, revolving it around the x-axis. If I solve this for y, it's going to look like y is equal to the square root of 1 minus x squared over 9. That would be the top half of this. Right? And we want to rotate that. So from negative 3 to 3 of this thing squared. So let's see. The antiderivative, the square root and the square cancel each other out. So I get pi times antiderivative of 1 is x. The antiderivative of x cubed, or x squared over 9 is x cubed over 27. Negative 3 to 3. So that gives me pi times, plugging 3 in here, I get 3 minus 3 cubed is 27 over, something's not right here. That would just give me 0, wouldn't it? Let me see what I did wrong here. Oh no, sorry, it doesn't give me 0. That part gives me 0. Gives me 1, right? Sorry. So that's 3 minus 3 cubed is 27 over 27 is 1. There we go. Minus, when I plug negative 3 in here, minus negative 3 cubed is negative 27 over 27. Now that's going to turn into plus 1. Be real careful with the signs here. So it's 2 minus negative 2 is 4. So 4 pi is the volume of that. And last one, we've got the base of a solid is the region in the first quadrant enclosed by the parabola y equals 4x squared. The line x equals 1, and the x-axis. So that would be this region here. That's x equals 1, so this would be the point 1, 4. And each plane section, each slice perpendicular to the x-axis is the side of a square. So that means the side of each square is the function itself, and the area of each one of the cross sections would be the side squared. If you haven't noticed yet, they really like the solids with square cross sections. Okay, so that means we want to take the area. Notice the cross sections are squares, so there's no pi out here. And they will give you the answers with the pi's on them, just in case you forget that this is not a solid obtained by revolving anything. It just has square cross sections. So we're just taking the integral of the area, which is, let's see, from 0 to 1, that's 16x to the 4th. From 0 to 1, antiderivative of 16x to the 4th is 16x to the 5th over 5. From 0 to 1, and that just gives us 16/5, which is D. So watch out for answer choice B. Okay, I think I'm going to put the answer for number 11 in a separate video because I have to kind of explain something that was not in your notes. Okay, so we'll end that video here, and you can look at that other video.